Matlab is a powerful numerical computing environment that provides an extensive capability for data visualization and plotting. Matlab plotting functions allows you to create a wide range varieties of plot to visualize your data, starting from a simple line plot and scatter plot to a complex 3D plots and customized visualization. On that note, welcome to Simplilearn YouTube channel. Today, we are here with a fantastic video on Matlab plotting, which will help you to learn how to use plotting functions in Matlab. Are you aiming to get certified as a data analyst and want to build your career in data analytics? In that case, you can check out the Data Analytics Certification course by Simplilearn, which will open the doors for the best career opportunities. To find the details of the Data Analyst Certification course, click the link below the description box. It could be an ideal solution to help you to build your career in the right direction. And we have a special discount coupon for our YouTube members. To avail that deal, use the coupon code YTBE15. And if you haven't subscribed yet, please subscribe to our Simplilearn YouTube channel and hit the bell icon to never miss an update from us. Before we get started, here is a question for you. In Matlab, what is the command used to save a command window text to a file? Let us know the answer in the comment section below. Now just quickly go through on the agenda for today's session. Today we will start the session by understanding what is plotting. Then we will move on to learn how to create plotting. Then we will learn how to create multiple plots. Followed by we will learn how to add line, color and marker style to a graph. Then we will learn how to generate subplots. At last, we will learn some of the 2D plotting functions in Matlab. Now let's begin the session by understanding what is plotting. Plotting is a graphical representation of a data set that indicates the relationship between the two or more variables. Matlab plotting plays an important role in the fields like mathematics, finance and statistics, and data analytics. Now it's time to learn how to create plotting in Matlab.
Creating a plots in Matlab is very easy. If you are creating 2D plots, you have to take a vector A coordinates and a vector B coordinates and connect them by a straight line. I am taking a variable A which is equal to 1, 2, 3, 4 and we'll take a one more variable B which is equal to -1, 0, 1 and 2. In Matlab, to create or to plot any graph, we use a plot function. So I am using a plot function and pass a variable A and B. As you can see, we have got a line graph where -1 corresponds to 1 and 2 corresponds to 4. Similarly, 0 corresponds to 2 and the 1 is corresponding to 3. Like this, you can get a simple line graph using a plot function. Now, what if the vector A and vector B does not contain the same number of elements? Can we plot the two vectors which does not have a similar elements? Let us try. I am taking one more variable as C which is equal to 1, 2, 3, 4 and 5. We have 5 elements in vector C. Now I'll take one more vector which is called D which will be equal to -1, 0 and 1. Again we will use same plot function to plot this. Plot of C, D. As you can see, we have got an error because in the plot function the vector must have the same length. Then only we can use the plot function to plot any graphs in Matlab. Using this plot function, we can also plot some trigonometric functions like sine, cos, tan, secant and cosecant. Now let's try one. For example, first I'll take a variable A which is equal to some elements like 1, 2, 3, 4, 0, 5, -1 and 3. And I'll take a one more variable C which is equal to sine of E. Now again using the plot function, we will plot A and C. As we can see, we have got a graph according to our values, that is, we have given some mixed values of integers and negative numbers. According to that, we have got the graph. Now, what if we use the standard functions of graph, that is using pi, 2 pi, 3 pi, like that? Let's try. For example, I'll take A is equal to 0 to pi. To represent pi in Matlab, we will use p and I divided by 100 from 3 to 3 into pi, and with the semicolon. Now again I'll take a variable c, which is equal to sine of a. Now we will use plot function to plot a and c. As you can see, now we have got a perfect sine wave for our equation, that is 0 to pi divided by 100 to 3 pi. As you can carefully observe the graph, it starts from 0 and increments to pi divided by 100 and stops when it reaches 3 pi. In Matlab, it automatically increments by 1. Now let's see how to add title, axis labels and annotations to this graph. To add a label to x-axis, we'll use a function called xLabel and we'll pass the name of that label as x within the single quotes and end with the semicolon. If not, you can also leave it like this one, that only. And then for y-axis, we'll use same y label and I'll give as a sign of that x and close the bracket. And to give the title for that graph, we use a function called title, and within that we'll pass a title, that is a plot of the sine function, and close the quote and the bracket and enter. As you can see in the graph, we have x-axis labeled as x and y-axis labeled as sin x, and we have a title for our graph, that is plot of sine function. Like this, you can create a simple graph using plot function and add a title, x label and y label.
Now we'll learn how to create multiple plots in Matlab.
For that, first I'll take a variable a, which will be equal to some equation, that is 0 to pi, which is divided by 100 to 2 pi, and end with a semicolon. And I'll take a function c, which is equal to sine of a, which holds the results of sine a. Then I'll say plot a comma c. As we did before, we are plotting a sine wave. Then I'll say hold on. Hold on function is used to hold the current plot and edit that plot. Then I'll also take new plot and pass the same variable a and c, and also I'll pass one more variable, which is equal to r, which will represent the color map of our graph, and I am using a quotes to represent the dotted lines of our graph. One graph would be a normal line and another graph will be a dotted line, and end with the bracket. Now I'll use legend function and I'll pass sine and cos. Legend function takes the argument indicating the plot lines in their name. Now I'll just press enter. As we can see, we have two waves, that is a dotted one red wave, as you can, it is called a cos wave, and the normal blue line is a sine wave. The two waves here has been overlapped because we are doing it for the same equation. Now we will do same for the different equations. For example, now I am taking a variable b and assign an equation 0 to pi divided by 100 from 3 pi, and then I'll say c is equal to sine of that b. and I'll plot B and C. Then I'll say hold on, and I'll give one more equation which is equal to A, and I'll change this equation by 2 pi. Now I'll say C is equal to cos of that new equation, that is A, and semicolon. Then I'll say plot R A comma C comma the R, that is the color, and I'll say legend of sine and cos, and X label as X, and I'll say Y label as sine of X and cos of X. I'll just say sine X and cos X. And for title, I'm giving plot of sine and cos function, and just will say enter. And as you can see, we have our x-axis and y-axis, our title, and we have our legend where it says this first graph is a sine and a dotted line is a cos. Like this, you can plot a multiple graph in a single plot, in a single graph.
Now let's learn how to add line, color and marker style to the graph.
Now let's learn how to add line, color and marker style. Let me just clear my screen and clear all the variables. A style option in plot command are the characteristic string that consists of one or more characters that specifies the color and the line style. To make it more clear, I'll take an example of a vector which consists of elements from 1 to 5, and I'll take a vector b which is equal to some of the elements like 0.5, 10.5, 40.0, 36.1, and at last I'll take it as 5.3. Close the bracket. Make sure if our vector A consists of 1 to 5 elements, then the vector B also consists of 5 elements, that is 1, 2, 3, 4 and 5. We have 5 elements, and then I'll just say plot A, B, and now I'll specify the marker size. The marker size should be oval and the color should be K. K represents the black color, and I want the graph line should be dotted. So I'm using this quotes and just enter. As we can see, we have got a graph with a marker style oval and a dotted line and a color black. Like this, you can customize your graph using any of the marker style, color and the line in the Matlab.
Now it's time to learn how to generate subplots.
The subplot function is to display the multiple plots in different subregions on the same window. The subplot functions require 3 arguments. For example, if we take that 3 arguments is m and p, m cross n will be the matrix and p will be the parts of window. Now let's understand it with an example. Before that, I'll just clear the screen. First we have to create a vector. For that I will take a variable x, which is equal to some equation that is 0 to pi divided by 5 to 3 pi. 3 into pi, this is my equation I am taking. Then we have to create a set of matrices using the cylinder function. For that I'll take a variable as a, b and c. I'm taking a 3 different variable, which is equal to, I'm using the function called cylinder. Within that I'm passing a function that is phi into cos of rx and end with the semicolon. Now this cylinder function will return the coordinates of the cylinder unit. I have to just press enter. Now we will enter the subplots. Using the keyword we will use subplot of, as we discussed, we have to pass a 3 parameters, that is I'll give it as 2, 2 and 1, and I will name that as a mesh of A, and I'll give it as a title, which title will be A. Just forgot to do this, and then once subplot is created, likewise we will do the same as replacing the values, as I'll do it as position 2, and it will be for B, and the title will be B. Again same thing, and now the position will be 3 and it will be for C, and the variable title name will be also C. Now at last I'll take one more position, it will be 4, and the mesh will be for all 3 together, like is 1, like I'll give all the variables, that is A, B and C all together, and the title will be like same, that is it will be A comma B comma C. Now we will just, there's a small mistake, I'll just delete this and enter. You can see we have 4 different plots plotted in the same window which is equal to subplot A, subplot B, subplot C and subplot ABC together. Like this you can create subplots and you can create multiple plots in a single window.
It's time to understand some of the 2D plotting functions in Matlab. We have numerous different categories in 2D plotting functions like line plots, data distribution plots, discrete plots, geographical plots, polar plots. And we have numerous subcategories in each categories, like line plots contains line plots, log plots and functional plots. In data distribution plots we have histogram, pie charts, etc. In discrete data plots we have bar graphs, scatter plots, etc. In geographical plots we have visualization of data and map. In polar plots we have polar in polar coordinates.
The first category is line plots. In line plots we have 3 different categories, that is line plots, log plots and function plots. Let's have an example for line plots. For that I'll take a variable A and I'll give a line space of, within the line space I am taking an 0 is x1 potential and 2 pi as is x2 potential and 100 is the number of points. And I'll just close it by the semicolon, and I'm take a variable y and I'll just say it as a sine of x, which returns the results of sine x, And as we know, for simple line plot we will use a plot function, and we will plot x and y by passing the variables and enter. As you can see, we have got the simple sine graph for our equation. Like this, you can plot any type of line plots using a plot function. Well, coming back to log plot, I'll take one more variable which is equal to x, and we have to pass a value for that variable using a log space. Within the bracket, I have to pass the values. I'll take it as value a as -1 and value b as 2 and the semicolon. Then I'll just take one more variable which is equal to y. Y is equal to 2 to the power of x. Here just have to mention dot. I just made a mistake. Now I'll use a function called log of x comma y, and also I want the grid of my graph to be on, and also I'll say grid on. As you can see, we have got our log plot, which is for the equation y is equal to the power of x, and our grid of our graph is also on. Like this, you can also plot the log plot. Now coming back to function, we have to use a fplot function. For that, I am using the fplot at the rate of, within the bracket, at the rate of one more bracket, x sine of x. As you can see, we have got a function plot for sin x. Now we will try the same function plot for two different equations, that is sin x and cos x. For that, I'll just take a variable xt, which is equal to a function plot of a t into, I'm just passing the equation of cos 3t. This is the equation for xt. Likewise, we'll just give it another equation which is of y of t, and it will be of sine 2t. Now using fplot, you will plot xt versus yt. You can see we have two graph, that is a cos 3t and sin 2t has been overlapped using, and we have done this using a function called fplot, which represent the function plot. Coming back to our second category, we have data distribution points. In data distribution points, we have histograms, pie charts, etc. Let's see how to implement them in Matlab. First, I'll just clear my screen and the workspace. To create an histogram, I'll take a variable x which is equal to a random integers from 1000, 1. And I'll take a variable h which is equal to a histogram. To plot histogram, I'm using a keyword called histogram of the variable which has been created, and enter. We can also customize the width of the histogram using the function bin width. That, for example, I'll take that variable h and I'll pass, I'll say histogram of the same variable x, and I'll specify the bin width. This should be within the quotes, and the width is 5, and just enter. Now as you can see in our graph, we have created a histogram plot where the bin it is 5, that is 0 to 5, that this is 0 to minus 5 to 0. Now we will move on to one more example of this category, that is pie chart. In pie, we can create a pie chart using a keyword called pie. For that, I'll take a variable again x, which is equal to 1, 3, 0.5, any random variables like 3.4 and 9. I'll just call a function that is pi of x. You can see we have a pie chart which is of 56%, 6%, 18%, 3% and 2%, which is divided based on a value on given in the variable x. Now I'll just use a function called xplot, which will create a gap or differentiate our pie plot. It is like 0, 1, 0, 1 and 0. This is the value for explode, and again I'll call a function called pi explode. First we have to pass a variable comma explode, close with the brackets, enter. As you can see, we have gave some space between the graph and separated some pie plots in the given plot. We can do this giving an explode function and passing a value for that. Now we can also label our pie chart by using a keyword or a function called label. And a third category is discrete data points. In discrete data points, we have graphs like bar graphs, scatter plots, etc. Let us take one example of bar graph. Let me clear the screen. I am taking a variable x which is equal to some values like 1, 900 to 10 to 2000. And I am taking a variable y which is equal to some values like 75, 91, 105, some of the floating points, and also 131, 150, 179, 203, 249, 185.5. Now to plot a bar graph, I'll just take a function and pass the variable x comma y. As we discussed before, the length of the two variables must be same. I'll add one more to this list, that is comma 226. Make sure the variable, the vector x and the vector y, or the variable x and the variable y must contain the same number of elements. The length must be same. Now I'll call a function that is bar x comma y. You can see the bar graph has been created here based on the timeline from 1990 to 1900 to 2000. Now what we'll do, we'll group this bar graph and display them in a group. For that, I'll take one more variable y which is equal to 2 comma like 2 space 2 space 3, and one more group which is 2, 5 and 6, one more group of 2, 8 and 9, and one more group of 2, 11 and 12. and I'll pass this y into a bar. Now you can see we have 4 different group of variable which is equal to 0 to 2, 0 to 2, in between 2 and 4 which is equal to 3, same as 2, 5, 6, 2, 8, 9 and 2, 11, 12. Like this you can also create a different group of bars and display them in a single graph. Coming back to our next category, which is polar plots, plotting polar coordinates. For that I'll take a variable called theta, which is equal to our coordinates, that is 0 to 0 dot 01 to 2 into pi, and with the semicolon. Then I'll take one more variable and I'll give an equation, that is sine of 2 theta into cos 2 theta, and with the semicolon and enter. Now I'll just use a keyword called polar plot of theta into this. I just made a mistake in the polar. See, like this we have got this polar plot for the equation of sine 2 theta into cos 2 theta. This is the format of a polar graph. It will be in the form of flower. As you can see, it looks like a petals of flower, and this entire graph is in the form of flower. The last category is animation. To display an animation line, we use a loop to add 1,000 points of line. After adding each new point, use a draw down to display the new point on the screen. Now let's create this displayed animated line in Matlab. For that I am taking a variable h which is equal to animated line, which is our function. Then we'll take axis is of 0 to 4 pi and minus 1 to 1. Close the square bracket and column and enter. Oh, I just forgot to mention I here, pi and enter. Okay, now I have to use two variables. For that I'll take first variable as x, which is equal to I'll create a line space of 0, 4 into pi and 1,000, which is the number of points that we have to create, and end with the semicolon, and one more variable which is equal to y is equal to sine of x, and with the semicolon, enter. Now within a for loop, that is for k is equal to 1, starting from 1 to length of our x. Now we have to add points. Within that we are adding points to our h, x of k and y of k. Now we will use a function called draw now, and end the for loop. Now just brush up all the plotting function that we have learnt in this tutorial by running some examples on the plotting a graph. First, I'll take an variable x which is equal to a line space . Inside that, I am passing a value that is 0, 2 pi, and the number of points as 100, and I'll press enter. Now I'll take a variable that is I'll just say it as sine of x. Just we are plotting a simple sine plot. Now using figure function is also used to create a one more figure block. When you are dealing with the multiple plots or multiple figure block, you can create a new figure block and then generate your graph. Now I'll say plot x comma y. As you can see, we have just plotted a simple sine wave as we did before for an equation passing in the x variable. You can also label this, give title, and also you can on the grid, and we can also set the axis level. For example, you can give grid on and axis level as equal. You can see we have a grid is on and the axis is equal 0, 5, 1, 1.52, 0, 1, 1.52. This axis is equal. Like this, you can customize your graph based on the color, the line size, marker style, and everything. You can also save your plot as an image using the function as save as function. Like for example, I'll just say save as GCF sine wave. It will be the name which it will be form, and the format is PNG, and close the bracket, enter. I have to give it, sorry, made a mistake in save as. You can see in the file section a sine wave.png has been saved. Like this, you can save any graph that you have plotted in your file section and then download it if you want, or import it and use it whenever you need it. Here we have used a function called GCF, which stands for a get current picture and used to retrieve and handle the current figure. And also it passes an input argument to the save as function.
With this, we have reached the end of this session. Today, we have learned what is plotting, how to create plotting in Matlab, how to create subplots, and some of the 2D plotting functions in Matlab. Please share this video with your friends and family. For more such videos, please visit our Simplilearn YouTube channel. For any query regarding this topic, please mention it in the comment box. Thank you. Keep learning.
Hi there, if you like this video, subscribe to the Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, click here.